Right. So in the previous session, we had discussed about indefinite integration, the basic formula of it, right? And then the basic properties of indefinite integration. And we had also discussed the case of integration by substitution, where we learned how to do substitution of linear term in order to do the integration. So let's pick it up from that point onwards. This will be the final session in calculus for us as far as the learning part is concerned. Maybe we'll continue discussing doubts, etc. in a couple of future lectures also, but the theory part and the understanding part of calculus will be done today. The next topic we'll pick up after this will be kinematics. So let's begin. So quick recap of what we've learned about indefinite integration in the last lecture. So what we saw is that indefinite integration of a function gives us what is called the antiderivative. So Ix here is the antiderivative of the function fx, which basically means that if we were to differentiate that function Ix, we would get the original function that we integrated, which is fx. So this is the operation which is called indefinite integration, and then the basic formula, or we can say the set of formulae for it we saw, is integration of x to the power n is given by this formula.
So this is a revision, right?
Yes, this is a recap of what we saw in the last lecture. Okay. Provided n is not equal to -1. When n is equal to -1, this specific integration is natural log of x plus c. And we had also seen the formula for integration of sin x, which is minus cos x, and the integration of cos x, which is sin x, plus c, of course, c being the constant of integration, which is always there in I don't remember if we've seen the integration of exponential function last time, but you can write down this formula. Just check in the notes. I think we've just done sine and cos, right? Oh, we've done exponential. Okay.
So we did of sine and cos and exponential.
We've done that also. Okay. So these were the basic formulae. Okay, just do a quick recap of these. Okay, then in addition to this, we had seen properties. The basic properties of integration being that integration of a constant becomes a linear term. Then integration of a constant multiplied by a function becomes the constant times integration of that function. And finally, the distributive type of property, that integration of the sum or difference of two functions is equal to integration of the first function plus or minus the second function. So we saw that using these basic formulae and properties, most of these simple type of integrations that we will come across in physics particularly can be handled. Like most of the time we will not need anything beyond just this part as far as formulae and properties are concerned. So let's do some examples to begin with.
Sir, in the third formula, you have used plus minus both.
Yeah, see, if the sign between the two functions f1 and f2 is positive, then after doing the integration also we'll add these two terms. If the sign is negative, then we'll subtract these two terms. Understood now?
Okay, sir.
So let's do one question that will help us practice that also. Okay. Just try out these 4 questions quickly and send me the answers on the text message. Then we will go on to the next part, which is integration by substitution. We had already seen substitution of linear term in the last lecture. Today we will see one more type of substitution and then move on to the last part of integration, which is the chain rule. Which is definite integration, not chain rule. Yeah. Tell me any doubt,
we
Peter?
have to substitute. In this, we have to substitute any term.
No, none of these integrals, Peter, you have to substitute. You can do by substitution also, but it's not necessary here. You can do by expanding the term also.
We can expand the whole term. Express with the
Yes,
whole
yes. You
square.
can expand the whole square, no? Then it will be directly integrable. That also you can do, right?
Okay, sir.
Okay, very good. Rishita, Ayan, your answers are correct for the first one. Piyu, your answer is almost correct. One term is missing only.
Okay, sir, let me see.
Yes, Veer, your answer is correct. Yes, Swam, correct. Very good, I am correct for the second one. Yes, Sakshi, correct, very good. Sanvi, correct. Just add the constant of integration, don't forget. Okay, so let me just work out the answers. Yeah, many of you have sent correct answers.
Sir, screen is not visible.
Which one, Rita?
No, so screen is not visible. I was saying now
Now
it
it's
is.
visible now. Yeah. Okay. Okay. So I'll just put up the answers. Okay. And the methods. So quickly, let's go over them. The first one, x plus 3 whole square. We can do by substitution also, but here I'm just doing it by the simple method by expanding this first. So 6x plus 9. And then you just separate out the terms. Okay. So x cube's integration will become x to the power 3 by 3. X's integration will become x to the power 2 by 2. 9 is a constant term, so its integration is 9x, so plus c. So ultimately, this is our answer, x cubed by 3 plus 3x square plus 9x plus c. Most of you got this correct, some of you got this partially correct also, but as you know, in science and maths, partially correct is unfortunately not good. So you need to get this 100% correct. Okay.
So,
Yes.
so can you please explain the fourth step?
Fourth step means this one. This is
No,
this
so
only.
the previous one.
Previous one. So here we are using this formula. No? Integration of x to the power n is x to the power n plus 1 upon n plus 1 plus c. So for example, integration of x square, x to the power 2 plus 1, same formula we had seen in the last lecture. Similarly, integration of
okay,
x is integration of x to the power 1, right?
Yes,
Similarly, now that 9 dx will become 9x plus c because it's a constant. That is coming from that property. Okay. All right, let's look at the second one. So in the second one, we can just separate out the terms. So this will become x square, the half comes outside, and again keep the half outside and dx by x. So integration of x square we've just seen is x cubed by 3. So 1 by 2 into x cubed by 3 plus integration of 1 by x is the exception term ln x. Okay. So remember that this one, integration x to the power minus 1, same thing as this.
Sir, यहाँ पे तो कहाँ -1 is not there, no?
Sorry,
Sir, in
What?
second one -1 is not there.
1 upon x क्या होता है बेटा? -1 ना, x to the power -1.
1 upon x. Ah, yes.
This is the exception case.
So what did you do in first step? Half को मतलब समझाने start कैसे किया?
फिर आपने वो कॉमन दिया ना हाफ.
x cube plus 1 by 2x को आप पहले हाफ को बाहर ले लो, फिर x cube by x कर लो प्लस 1 by x कर लो. Okay. फिर उन दोनों टर्म्स को सेपरेट आउट कर दो.
So you
Understood,
took half as common, right?
Yeah, half is constant and it's common also. So it's 1 by 2x square plus 1 by 2 into 1 by x now.
Okay, yes. Sir.
Now you integrate this term. So when you integrate it, separate them out using the distributive property.
Sir,
So could you please wait?
Yeah.
Sir,
Yes.
can you show the second sum by substitution method?
Which one? The second one?
Yes, sir.
Second sum can't be done by substitution, but you have to separate it out. The first sum can be done by substitution, where you can substitute x plus 3 as z as a dummy variable, so it will become like a z square integration. But it will become unnecessarily lengthy by substitution. Second sum we cannot do by substitution, because there is no linear term like that now which can be substituted.
Okay, sir.
So for the second one, you have used which properties?
For the second one, I have used what beta? Which property?
Yes, sir, out of the
I
three
used
which
the
you
last distributive property, na? X cube plus 1 upon 2x so hai, usko I have separated out as the sum of two functions. See the above steps which I have written in red now. So it's
Yes,
becoming
sir.
half of x square plus half of 1 by x. And then I have separated out the two functions. The sum of two functions integration is sum of their integrations.
got it, sir. Done, sir.
And now, okay, let's come to the third one then. So third one is actually relatively simple question. You have to just simplify it one step. Write it as a single power of x by bringing this thing to the numerator. So x square by root x, we can write as x square upon x to the power half, which further we can write as x to the power 3 by 2. Okay, so this from this steps it becomes x to the power 3 by 2 dx. Right, and then just apply the formula directly. So this will become x to the power 5 by 2 upon 5 by 2 plus c, which you can write more nicely like this. And that's our answer. Okay, and the final one, this was the fourth one, and the fifth one was root x minus 1 by root x whole square. Yes.
Sir, you didn't get the third one.
Didn't get the third? Have you understood this step at all? How this came? X square upon root x, x to the power 3 by 2 hoga. Have you understood this?
No, so she's saying that you didn't solve the third one.
Sorry?
That was the third one only.
Oh, that was the third one, my mistake. Okay. Yeah, we have 4 questions in all. Anyway, so that's the third question. So you got the third one, no?
Yes, sir.
Yes,
Yes, sir.
sir.
Okay. Now, fourth one, you have to do the same thing like we did the first question actually. You know? Expand this. So this becomes x plus 1 by x minus 2 times the product of these two terms. So that's just 2. And then just separate it out. So x plus 1 by x is integration minus 2 is integration. So x is integration is x square by 2. This term will give you ln x, right? This term will give you 2x and just a combined constant follow it.
Sir, for the second one, you did dx upon x ka integration.
Yeah, that is the same thing as 1 by x का integration. ना? Dx upon x is the same thing as x to the power minus 1 into dx. Na?
Yes, sir. हाँ तो फिर okay, sorry.
Sir,
Yes, beta.
so integration of 2 will be 2 only, no?
Integration of
2.
2, yeah, it's a constant term, no, beta. 2 is a constant, so like integration of any constant is that constant into x. So like the integration of 2 dx. Is it clear?
Okay, so I thought like
Yes, sir.
the
Yes, sir,
integration
just a
of
minute.
2 will be 2 only.
Yes, Sakshi, what was your question again? You thought that?
I thought that integration of 2 will be like 2 only.
No, beta, because see, 2 is a constant, na? So its integration becomes linear. Na? Remember that property of integration, the first
Yes,
property?
sir.
Yeah, so that
Yes,
you have
sir,
to-
got it.
yeah.
Sir, in fourth one you used a minus b the whole square formula, na?
Yes, yes.
And then at last one you did integration, no?
Exactly.
Okay, thank you.
Okay. So we use the whole square formula first to expand this term, and then we are using the distributive property. We are having the sum of 3 things. So we are individually adding their integrations. Right?
Yes, sir, done. Sir, can you shift a bit up that
Okay.
side? May I want to write side?
Okay, just a moment. And shift it. Okay. So
Yes.
these are the same properties and formula, no? We've seen before also. I'm just showing here how we've used this in this question.
Done, sir.
Okay, done now? Okay. Now let's quickly revisit substitution once. Substitution of a linear term, how we had discussed last time. And then we'll see another type of substitution today. Substitution of when there's a composite function. Okay, so this is the last sort of method we will learn in indefinite integration. So
Sir, you first taught substitution of a linear term. Now the second one you are about to teach.
yes, we are going to discuss both.
Oh.
Okay. We'll do a quick recap of substitution of linear term. So for example, suppose we had dx upon square root of 3 plus 4x. Okay. Now we can see that this term 3 plus 4x, it's a linear term. So what we do is we substitute it. We substitute it as a dummy variable. Yeah. Okay. But when we substitute that, we have to substitute the dx also. So we'll say 3 plus 4x is z, which is my dummy variable. But now it is not enough just to substitute that, okay, because this now tells me that, okay, 1 upon square root of 3 plus 4x is a very simple term. It is 1 by root z. But I cannot integrate 1 by root z with respect to x. So in the numerator, that dx also has to be shifted. So for that, I now apply differentiation. So dz by dx is nothing but differentiation of what z is, which is 3 plus 4x. Now that is nothing but 4. So by cross multiplication, I can see that dx is nothing but dz by 4. So this term will be substituted and this term will be substituted, and the integration will become, in place of dx, I will substitute dz by 4, and in place of 3 plus 4x in the denominator, it become this. Now 1 by 4 is a constant, so I can just bring it outside and I can make this z to the power minus half, and then just apply the normal formula of integration. So it is 1 by 4 into z to the power minus half plus 1 upon minus half plus 1. So that is plus c, of course. So that is,
Sir,
yes.
sir, here, for second, third step, z minus half ke baad you wrote dz. So that dz doesn't value, anything.
That dz doesn't have,
मतलब कोई value नहीं है ना उसका.
because z is the variable of integration.
हाँ sir.
That is the importance of that dz term. No? We cannot see, whenever we write some integration, we can't just write 1 by root z and integrate it. No? We have to write either dz or dx or whatever to understand with respect to what variable we are integrating. Understood? Okay.
Sir, you differentiated 3 plus 4x, no?
Yes. Differentiation of a linear term is a constant. So just like integration of 1 by root x with respect to x is 2 root x, like that integration of 1 by root z with respect to z by the same formula is 2 root z. And then the last step is the resubstitution step, where we resubstitute z's value. So that becomes our answer. Just a second. Yeah, so this becomes our final answer here. I'll just write it more clearly. So the 2 and 4 will cancel, and the numerator root z ke jagah we can substitute z as whatever we had taken it as. So that was 3 plus.
So can you explain the last two steps?
This step is the formula, beta. Formula we just saw, na? N का value क्या है? Minus half. So what is the integration? Z to the power n plus 1 upon n plus 1. Is it clear now?
Sir, I'm sorry, but I got disconnected. Could you explain the last two steps?
Yeah, so integration of z to the power minus half dz, beta. We are using the formula of power n. No, integration of anything to the power n becomes power n plus 1 divided by n plus 1. So that n is minus half.
Yes, sir.
Understood? So once you bring 1 by
Sir,
root z in the
2,
denominator.
2 root 3, how that came?
2 root 3 कहाँ है बेटा?
Oh, sorry, it is 2 root z. Oh, sorry.
हाँ.
Sir,
Yes.
sir, I'm not interested that two roots and how it.
Sorry, what was the question again, beta?
Sir, I'm not understood how that two roots z came.
I didn't understand what your question is, beta. You have understood this question or not?
Yes, sir, I understood, but that second last step was then 1/4 into 2 root z plus c.
हाँ.
हाँ, उसमें 2 root z नहीं समझा कैसे है.
अच्छा, I'll explain. See, इसको एक step और solve करना है बेटा. So what is minus half plus 1? It's half, na?
Yes, sir, half.
So now understood, na? That 2 goes in the numerator. And z to the power half is root z, no?
Yes, sir, yes.
This here now. And in this z is what? It is 3 plus 4x.
Okay, and this. Okay, thank you so much.
Okay, okay. Okay, now we come to the second type of substitution, where we substitute a function gx within a composite function f of gx. Okay. So the description sounds very complicated, but we will start with an easy example of this and you'll see it's not that complicated. An example of this is, suppose I have cos x upon 1 plus sin x. Now this looks like something very complicated because we can't really separate out the terms and all that. But you notice one thing, that cos x is the differentiation of sin x. Okay. And the denominator term is actually 1 plus sin x. Okay. Where 1 is a constant. So this tells me that, okay, that if we substitute 1 plus sin x, that is a denominator, as a dummy variable z, okay, then dz by dx is equal to cos x, which is the numerator. So in cross multiplying this, we can see that we can substitute cos x into dx as dz. So the moment we do this, the integral is solved because the denominator is z. Okay. So this is the method that we apply in this type of function. So that's what we'll exactly do. So when we substitute in this integral, cos x dx, which is my numerator, will get substituted simply as dz. And the whole denominator, which is 1 plus sin x, is nothing but just z. So it's become a very easy thing. Dz by z's integration is ln z plus c. And then I just need to resubstitute. So that is ln of 1 plus sin x plus c. So that has become the integration.
Understood.
This is the resubstitution step.
So I did not understand.
Okay, just note this down step by step and we'll do more questions, you'll understand. So the important thing, the only thing to understand here is that numerator mein kya hai, cos x hai, or denominator mein kya hai, 1 plus sin x. Now if I differentiate 1 plus sin x, what we'll get? We'll get this thing, na? If you differentiate this 1 plus sin x, we get cos x, which is the numerator. That is the only thing to understand in this actually, nothing else. So because when you differentiate this whole term 1 plus sin x, you get the term which is there in the numerator, which is cos x. Therefore, we will substitute 1 plus sin x, the whole denominator, as the dummy variable z. Understood now?
Yes, sir.
Okay.
Sir,
Yes.
so it means how we will identify at a given time as a composite function, or
That you have to
is
learn with
there-
practice, na? Like you learned about composite functions in differentiation also before.
Sir, I am a little bit confused between composite and linear.
So that's what I'm saying. Na? Like in a linear term, it's very evident that the question has some linear term within the function. In a composite function, it's very evident that there is a function of a function.
Okay, sir.
Hmm.
So at the last, you have used that exception wala case, no?
Hmm.
Okay, sir, done.
Okay, so let's see another example of this.
Sir, 1 minute, can you scroll up? Last time.
Okay.
So you're giving examples to solve.
Yes.
Okay.
Yeah. So next example is for you to try out yourself. Okay, just try out this question. 2x upon square root of 4 plus x square, and you have to find the integration of that.
So I have sent you my answer.
Let's look at this question. So you can see here that 2x in the numerator is the differentiation of this term. If you take substitute 4 plus x square as z, then dz by dx is the differentiation
Sir,
of this term.
Sir, root of 4x square, right?
But वो तो root के अंदर है ना बेटा.
Root of 4 plus x square we will
तो उसको तुम
substitute.
z substitute करोगे तो फिर dz by dx you'll have to do by chain rule ना. That's so lengthy. You understanding ना?
तो ये जो आपने फॉर्मूला में किया है dz upon dx वो बाजू में एक बार लिख सकते हो. The property you have used. वो
There's no property used here, but I've just substituted 4 plus x square as z, and then dz by dx means difference. What is z? Z is 4 plus x square. So it's simple differentiation, no? What is differentiation of
okay,
4?
that's it.
That's step only. और कुछ नहीं है इसमें. There's no property used. So dz by dx is equal to 2x. That means if I cross multiply 2x into dx is what it is dz. Okay. So I can substitute this. And I can substitute this in the integral. So this integral will become what? 2x dx in the numerator will become dz, and in the denominator inside the square root, this term will become root z. So this is again integral of which type? Z to the power minus half dz. So this will become z to the power minus half plus 1 upon minus half plus 1 plus c. So that is 2 root z plus c, which is 2 times square root of 4 plus x square.
So we cannot simply write 4 plus x square raised to minus half.
Sorry, come again. We cannot substitute.
Sir, we found that final term is z to the power minus half. So that after that we have to do minus half plus 1 and denominator minus half.
Yeah, integration का formula use करना पड़ेगा ना. ये last वाले step में from here to here what we are doing integration. So we have to use the formula of integration only, right?
I substituted minus
Yeah.
z as 4 plus x square.
Yes.
But so how did dz by dx is equal to 2x came?
How did? dz by dx is equal to 2x is coming by differentiation, beta. 4 plus x square को differentiate करो आप. Z is what 4 plus x square, no? So dz by dx is what differentiation of 4 plus x square.
Oh, okay, sir. Okay, sir.
Sir,
Yes.
sir, always dz by dx value would be same as the numerator.
Yes, that's only the only case in which we can use this formula. I mean this method.
Sir, it can come different. The answer can come different for dz by dx.
Yes, it can come different.
Sir,
Yes, beta.
so if the differentiation of the denominator or like the dummy variable does not come out to be the numerator, then what will we do?
Then we can't use this method, beta. Okay, so this method is very specific.
Okay.
So
Okay.
we have to identify within the integration that whatever we are substituting as z, that term's derivative should be there. So here we are looking at, okay, what term is there in the numerator 2x, and in the denominator, okay, there's a square root function, but inside the square root, what is that? There's 4 plus x square. So if we differentiate 4 plus x square, the derivative is 2x, and that 2x term is there in the numerator. So we can use this
Yes,
method.
sir.
And if the numerator had
Understood,
something else, then we could not use this method. You understanding my point, no?
Yes, sir. Thank you.
Okay, beta.
Sir, then my answer is wrong. No, I wrote ln bracket root of 4 plus x square.
You have done the answer for this question, for a different question. You have done it for 2x dx because it was divided by 4 plus x square.
So that root
Then we would do this. We would substitute 4 plus x square as z. Okay, so 2x dx
Yes.
becomes dz. So the integral would have become dz by z. So that would have given us this one, ln z plus c. So it's a slightly different question that we have solved. Okay.
Sir, can you give more sums to practice?
Yeah, we will be doing more sums with that. Okay, another example of this. Now see, always.
Just a minute, sir. Last step is remain.
Okay,
Last step.
Okay.
Yes, certain. Thank you.
Okay. Now, always it need not be that what we are looking for is in the denominator. It can be in some other combination also. Like for example, we would have something like this, that we have e raised power x cube into x squared dx. Okay, like this. Now you notice that this term x cube. Now this x cube is such that if we take z as x cube, then what is dz by dx? It is x square. And x square, sorry, it's 3x square. Now x square term is there now. So we can do that substitution here. 3 is not there, is fine, but 3 is a constant. Okay, so we can just substitute. So we will substitute x cube as z. So dz by dx is the differentiation of x cube, which is 3x square. Now on cross multiplying, we can see that x square into dx is dz by 3. So that by 3 does not create any problem because it's a constant. Okay, so this and this will be substituted. So the integral becomes e raised power z into dz by 3. Yes, you have a question, beta?
सर वो आपने कैसे लिखा x square dx is equal to dz upon 3? That
Cross multiply करके बेटा. See, this term, what it's telling me that dz by dx is 3x square, no? Now transfer the dx on that side and the 3 on this side, so you'll get this. Understood now?
yes, yes.
Now integration of e raised power z is e raised power z only. Okay. Just like integration of e raised power x is e raised power x only. Okay. That becomes our answer. Okay. So note this example down and try one more question after you do this. Now suppose we have this e raised power sin x into cos x. Try to use the similar kind of logic here, like I've done for the above question.
So this one we will solve.
Yes, solve the last one yourself. After going through this second last one.
Yes, sir. सर x क्यूब का आपने डिफरेंशिएशन किया ना इन सेकेंड स्टेप.
z को अगर मैंने x क्यूब लिखा है तो dz by dx क्या आएगा? x क्यूब का डिफरेंशिएशन ना.
x क्यूब कर लिया. ओके, राइट. Sir, in the previous and last में what you did? I is equals to that.
Sorry, come again, beta.
Sir, this I is equals to that line. That what you did?
उसमें substitute किया ना, देखो. This integration, the original integration, x cube को क्या substitute किया है?
अच्छा, understood.
This is, so this integration when I substitute, so e raised power x cube into x square dx. Okay, so this x cube I'm substituting as z, and this whole term I'm substituting as dz by 3.
By 3. Okay.
Okay, now let me see how many of you have done the next question. Yes, correct. Sanvi, you have to resubstitute the z. Swam, your answer is correct. Very good. Veer, your answer is correct. Rishita is correct. Very good. Yes, it's correct now. Yes, Sakshi, that's correct. Very good.
Sir, differentiation of sin x is cos x, no? Huh. Sir, I was writing. हाँ. Yes, certain.
We come to the last part of calculus, which is the part called definite integration. That is when we put the limits on integration. So the method of solving is actually the first aspect is what we've learned in indefinite integration. I'll explain to you. So it's not going to be anything very new, but okay. So when we have the integration symbol with two numbers here, which I've written as E and B, it is called definite integration. And these two numbers are called the limits. Okay. So this whole symbol is read as the definite integration of the function fx with respect to the variable x, of course, okay, from lower limit x equal to a, whatever we've written below here, to upper limit x equal to b, whatever we have written above over there. And its value is calculated by doing this kind of an operation. First, we conduct the indefinite integration. And then in the antiderivative, we put the value of the upper limit. Yes, PO, what is your question, beta? Minus the value of the antiderivative at the lower limit.
Sir, I indicates antiderivative,
Yes.
and here A and B are constants or variables?
They are constants, beta. They're numbers. Okay.
Constants.
So it is the antiderivative of fx. So let's understand this with an example. It will become very clear. So suppose we are integrating, let's say, x square, but we also put these two values, 0 and 1. So that means we are doing definite integration of the function x square, okay, from lower limit x equal to 0 to upper limit x equal to 1. So first step, what we'll do is we'll calculate the antiderivative of x square, which we know is x cubed by 3 plus c. And on this antiderivative, we'll put the same limits 0 to 1. So the upper limit is the value of this antiderivative when x is taken as 1. So that is 1 cubed by 3 plus c, minus the lower limit is when you take x's value as 0. So 0 cubed by 3 plus c. As you can see, it is 1 by 3 plus c minus c. So c cancels out and we get a definite answer. Okay, so the value that we get, it's a definite value. It is not a variable, it is not an indefinite term. So that is why it is called definite integration.
So can we please write?
Yes, write this part down. This is the definition of it. Okay. And as you can see, it's very simple. We just need to first calculate the antiderivative. And then in the antiderivative, we just need to substitute the upper limit b, substitute the lower limit a, and subtract the two terms. So when you subtract, the constant of integration goes away and you just get a numerical answer. So always definite integration will give us a numerical answer, or it will give us a definite value. It will not give us the antiderivative finally, because we have substituted the limits on the antiderivative.
So, sir, we have to substitute x as a and b, the value like.
Yes, whatever is written on the lower part of the integral symbol, that is the lower limit a. Whatever is written above, that is b. So ib is basically what? The value of the function ix at x equal to b. Got it now? So in the example below, what is the antiderivative? It is the function x cubed by 3 plus c. अभी उसमें upper limit क्या है? 1 है. So what is ib? It is the value of that function x cubed by 3 at the point x equal to 1.
So
Yes.
can you please explain what you have written after the question, because I got disconnected? I'm sorry, sir.
Question.
That 1 by 3 cube plus c, that one.
That x cubed by 3, that part.
Yes, sir.
Yeah, so see, in that now we are substituting the upper limit as 1. So when you substitute upper limit as 1, x के value पे हम क्या put करेंगे? X को equal to 1 substitute करेंगे. So what is the value of that function? It is 1 cubed by 3 plus c. Got it?
Yes, I got it.
Minus the value of the function at lower limit. Now lower limit क्या है? 0 है. तो again वो function में मुझे क्या substitute करना है? X के value को 0 substitute करना है. So lower limit तो उसका value कितना होगा? 0 cubed by 3 plus c. Okay.
You use that I into b minus I into a, that one, right?
I didn't follow better. What was the question again?
Let it be, sir. I got it.
Okay. So understood why c cancels out, no?
Sir,
Yes.
sir, in this example that which you wrote definite integration, वो ऐसे exam में भी लिखना होगा.
Yeah. Definite
That is
integration is part of
compulsory.
your, yeah, it's compulsory. It's part of your. Okay. So let's do one more example question. This time let's take the function sin x dx and let's integrate it from pi by 2 to pi. Instead of 0 to something, let's integrate it from some non-zero value to some non-zero value. So the lower limit is pi by 2, which is the same thing as 90 degrees. The upper limit is pi, which is the same thing as 180 degrees. So let's see how we'll calculate this. Just try to apply the above steps here.
So could you please read
Sir,
that
here we
limit?
will,
Yeah, Rishita, what was your question, beta?
so here we will get like a set of values of x, right?
Set of values of x here, beta. See, we will get what does
Like
the
between two
but
numbers.
it's from one limit to one limit, na? It is from
Yeah.
A to B. Okay.
Yeah.
So when we substitute in the antiderivative, we have to only substitute the upper limit and then subtract and substitute the lower limit. And it is the value of I at B minus the value of I at A.
Yes, sir. Got it, sir.
Understood the point? Na?
So
Yeah.
first we do differentiation and then we do that process.
नहीं differentiation नहीं बेटा, differentiation से कोई मतलब ही नहीं है, यहाँ पे integration है.
Sorry, integration.
हाँ.
Confusing.
So what is the antiderivative of sin x?
Minus cos x.
Cos x.
Yes, minus cos x.
Cos x.
So first step we put here minus cos x in place of ix plus c. Okay, and on that we have to substitute the lower limit. A का value क्या है? Pi by 2 and upper limit b का value क्या है? Pi. Okay, so now what is my ib? It is the value of this function at x equal to pi. So it is minus cos pi. Okay, and lower limit is minus cos pi by 2. In fact, you need not write the c also because it always cancels out. Okay. Yes, very good, Ayan, that's correct. So with practice, you will see that you don't need to write the c. It's just 2 minutes. Okay, so you just need to cancel this out. Okay, so minus of minus 1. Okay, and cos pi by 2 is 0. So this becomes how much? This becomes 1. So this is the answer.
So minus 1.
अरे cos 180 कितना होता है बेटा? minus 1 होता है ना? Cos
Acha,
pi.
oh, sorry.
Right?
That is 90, that is 180. Okay.
Okay.
Sir, your screen got disabled. Is anybody able to see Sir's screen?
Sir, hello, sir.
Hello, sir.
Sir, are you there?
No, sir is not there. Maybe sir got
He's there in the meeting,
disconnected.
right? Yeah, meeting में है, but like his mic is on. He might be facing.
Last time also he faced some issue, no?
Let's wait for another 5 minutes, then we shall leave because पता नहीं मतलब group में भी message नहीं आया like that.
हाँ, some internet problem होगा तो फिर maybe he cannot even send messages.
Should we leave or should we have to stay? We have to stay.
I guess we could leave at 8:15.
Yes, because sir is giving no response.
Let's wait till 15 and then I guess we should leave.
Because the lecture.
Yeah. Should one of us call sir?
I called just now, but he isn't picking up either.
Oh, okay.
Students, sorry, there was complete outage here of power. I don't know how many of you are online. Okay, 21 people online. Okay, so students, we will take this from next lecture onwards. We'll conclude today's lecture here. Okay.
Sir, did you
Anyway,
say something?
if you understood integration, definite integration with the limits, then you can complete integration from the module now. Next lecture, we'll discuss the doubts and questions. Okay. So that's it for today's session, people. I'm ending the lecture here.
Sir. Excuse me, sir.
Thank you, sir.